question, and we read the equation very carefully. T versus H. H is the height above the ground, and T is the time after the ball was hit. So the ball was hit, T would be equal to 0. So usually sometimes it would say the initial height of the ball. That means when T equals 0. This question says write down the height at the instant it is hit by the bat. So when T equals 0, we substitute in here and find the value. Find the value of T when the ball hits the ground. Well, if the ball hits the ground, the height above the ground will be 0. So this is part A, make T equals 0, and part B, make the height equal 0. So the best thing to do would be to go ahead and plot a graph. So negative 4.8. Instead of the variable t, of course, we have x squared. Just go back, make sure we get the right one, plus 21t. Oh, try that again. Negative 4.9x squared plus 21t plus 1.2. And look, the t here and the x squared aren't going to work, so the t must be x, and I put 2 instead of a squared. So there's lots of little mistakes you might make, but the graph will tell you that you've been a bit silly and you haven't plotted it correctly. So negative 4.8, oh there we go, let's go make an adjustment, negative 4.8. It'd be nice to see the up and down, right? The best way is Control T, the table of values, and then look, when t equals 0, the h is 1.2, t equals 0, h is 1.2, so we can go and fill that in. So when t equals 0, the full working out would be h of 0 equals negative 4.8 times by 0 squared. Put a little 0 in here. Okay, and that'll be plus 21 times by 0. Oh, that's a little, that's an O instead of a 0. Plus 1.2. So can you see that actually the 1.2 is the y-intercept, and that's the height of the ball above the ground when it is hit. And so here h of 0 equals 1.2. And then for the second part, we actually want to know where the ball hits the ground. So we're going to put when h equals 0, find t. That should help us with our understanding. And if I look at this graph, look, it goes up to a height of about 20, 21 here, 24. So I'm going to Control T again, take off the table. And now I'm going to do this quickly. Double click 26. Double click on the X. I'm going to call 7. And that looks alright. Maybe negative 1. That looks great. Now menu, analyze a graph. Look at the 0. Click before, click after, and there we go. After 4.43 seconds, the ball is 0 meters above the ground. So find t. We just put t equals 4.43 seconds. We might just put solving h of t equals 0. That's all you need to put for the explanation here, and t equals 4.43. If you want, you could sketch by hand a little picture of the graph there. And then finally, state an appropriate domain for the model. So the domain for the model, remember, are the x values, and this is quite an easy one. 0 is the lower bound, so 0 on the time, all the way up to 4.43. And if we go and write that down, 0, we need to get the less than or equal to signs. They can appear on the magic button, which is Control equals. Control equals. And notice we can equal 0. That's the time where it starts, the bat hits the ball. And we finish at the 4.43. And that's your full answer. You can go ahead and modify this function so it starts at 0. Let me show you that. Double click on the function and I want to draw a graph of this. Control equals again, and it's this little sign. This sets the domain, and we want the x value to be, well, actually we can just copy across, can't we, from what I've just written down. So control this one equal to, and I'm just going to copy across this. You would have to maybe type it up on your machine. That's all right. Control given that, and then type in the domain, change that to x. Look at that. Isn't that nice? So it starts at x equals 0, and it finishes, well, look, I mean, maybe because of the pixels, it doesn't finish quite on the intercept here. But if we made this 4.43 a little bit more accurate, then it would for sure cross at this intercept.